hopefully you're looking at question 4 from section 5.4. So here it is. And I want to go over that question because it's been causing a lot of trouble with my other Calc 2 class. So I'm sure that when you get to that question, there's a good chance you're going to have a problem with part B. Most people got part A correct, and that is fine. If you ever look at WebAssign questions, if a number or a thing is in red, it's a variable in the sense that WebAssign will change it. So if you phoned up John and said, John, I'm in question 4, what's going on? His question 4 will probably not be your question 4, right? So you can't really use each other to do the same question together kind of thing. So it's not really practical. So I'll set this fella up and then I'll go to my white screen and we'll look at what's going on. In this question, you're told the acceleration is 2t plus 2 and the velocity at time 0 is -15. And we're interested only in this object that's moving in the first 5 seconds. And question A wants you to find a formula for the velocity at time t. And question B wants you to find the distance traveled. Okay, so once we got the question set up, let's have a look at it. And it looks something like this. Oops. Keep an eye on me tonight. 2 times 3 will probably turn into 5 and the usual kind of oopsies, right? So if you notice anything, just shout out. Right, let's do the velocity. If you're told the acceleration and you want to get the velocity, what you do is you integrate the acceleration function. It's equivalent to working backwards from Calc 1, right? You know, if you differentiate the velocity, you get the acceleration. Well, if you integrate the acceleration, you get the velocity. It's for that reason. So the velocity is a pretty easy function to integrate. It's an indefinite integral. And so you'll get t squared plus 2t plus c. And that's cool. And then I'm going to use this fella up here. And I'm going to use them to find out who c is. So if the velocity at time 0, which is what? 0 squared plus 2 lots of 0 plus c has to equal -15, that means c is the number -15. That's what that is. So I now have the answer to A. The velocity at any given time is t squared plus 2t, take away 15. Oh, one of the 3 people that are missing has just turned up. As I said, very few people who did this question seem to have trouble with that. It's part B now. The question is, this is the full wording of it. Find the distance traveled during the given time interval, which is this here. Now, there are 2 kinds of things in physics to do with distances. One is the distance, which is what they're asking, and the other thing is called displacement. Have any of you done classes where they mentioned the word displacement? It would be in a physics or a kinematics class. Anybody recognize displacement? Yes. Yeah. Now, displacement is not the same thing all the time as distance traveled. I'll give you an example. If I was in my house and I traveled 5 miles north and then I traveled 4 miles south, my displacement would be 1 mile, because that means I'm 1 mile away from where I started. So displacement is the distance away from your starting point, and it can be a plus or a minus number. That's displacement. If you were being asked to find the displacement, the answer would be the integral from 0 to 5 of the velocity function. but it's not. That's the trick. That's the fault of the question. They could have made it so much clearer. In fact, they should have just asked for displacement and made life easy. When you're being asked to find the distance travelled, if I went 5 miles north and then 4 miles south, I've walked 9 miles. That's what distance looks like. You see, one of them is 1 mile and the other is 9 miles. You notice the difference. So how do we find that fella out? Well, it's actually more work than you think it should be. I'm going to do a sketch of this velocity function. And it looks something like this. And you can put it into your calculator and check it out, but it does. Now, have you noticed that some of this shape is above and some of this shape is below what would have been the x-axis, but now is the t-axis? So if I want to find the displacement, I have to find the area of this guy, I'm going to call it A, and the area of this guy, and I'm going to call it B. Well, let's do this one first. The integral from 3 to 5 of this guy. Now I want A, right? So that's how you get B. Now I want to get A. Well, A is from 0 to 3 of this guy. But here's the problem, and this is where things went wrong. If you just took this number and you added it to that number, you'd end up finding displacement again. What do you know about the answer to the area under the curve A? Is it positive or negative?
Negative.
Negative. So what you got to do is you find this guy, and let's just pretend, I don't want to do the whole question, but let's just pretend that the answer is negative 10. We don't use that. We use 10. And let's suppose we did this and the answer was, just for argument's sake, 15. This is positive and we do use it. So the distance traveled is going to be those two things added. And that's where the problem went, right? Now, don't quote me on the 15 and negative 10. You know you're going to have to do that and find out what the real answers are, right? But that one will definitely be positive, right? And this one will definitely be negative. And whatever that negative number is, make it a positive and add it to whatever that number is. And that will be the correct answer to question B, the distance. Are we good? Any questions about that? Or hopefully I've given you enough help.
Seems good.
Seems good. Good. Right. You can tell me this is what I recollect, but I'm old and I don't always recollect the right thing. Oops. We have gone over what were called standard integrals. Have you seen these kind of guys and what their antiderivative looks like? Great. We have done indefinite integrals and definite integrals. The indefinite integrals are the ones we are plus c, and the definite integrals are like from 1 to 2 and 5 to 7. Is that correct? Is that what we covered? Right. At the end of Tuesday, did we just scan through and talk about some of the questions and then we've called it a day? That's what I think I did. Got a nod, so I'm going for it. So what I'm going to do now is just do some more of these questions, but instead of skimming through them, actually do either the whole question or at least a good chunk of it. So first thing I'm going to do is look at our homework. So here's question 5, and we're being shown that the integral of sine squared x dx, and we're being told it is a half x, take away 1/4 the sine of 2x, I'd say. And we're being asked to decide, is this true or is this false? So let's get started on that one. Unless I've already done it. Is this new stuff? Okay, good. Now, they do mention that you have to use differentiation to help you. Well, if you take this expression and you differentiate it and you get this guy, then the answer will be true. Can you see if you find an antiderivative and you get an answer, if you differentiate the answer, shouldn't you get the guy that's inside the antiderivative, right? This guy here. So I'm going to take this, I'm going to differentiate it, and I'm going to see if I get sine squared. If I do, I'll say true. If it's not sine squared, I'm going to say false. So here goes. 1/2 x, take away 1/4 the sine of 2x. I'd say. I'll get its derivative. If you differentiate a 1/2 x, you get a 1/2. If you differentiate negative 1/4 sine 2x, you get negative 1/4 cosine 2x times something else. So you've got to remember differentiation and chain rule. If you differentiate 1/4 sine 2x, you get negative 1/4 cosine 2x times what else?
The sine of x.
Well, I've done that part. No, we've done the sine and the cosine. What do you do next? What does that 2x give us? That's what I'm getting at. According to differentiation, we're differentiating right now. You differentiate, yeah, that's what I was looking for. What will the plus c get you if you differentiate a number like +4 or +c?
0.
Right, so it disappears, so I'll not write it. Now, that's the derivative. It doesn't look like that, and maybe it isn't that, but I'm going to take it slowly. 2 times that gives me this. And now I'm going to pull out a common factor of 1/2. And one of the really awkward things about trig are there's things called trig identities. And there are quite a few of them. And this is one of them. Does anybody know what that is equal to? And this is from 142, because it is equal to something. You could probably guess what it should be equal to, and you'd be right. But what is that equal to?
Sine squared x.
Yeah. And because it is equal to sine squared x, that means the whole thing's true. Imagine that I got this as my answer. A different question, but imagine I got this as my answer. Does anybody know what that guy is equal to? Up here's a bit of a clue.
Cosine squared x.
It is. Now you may have just assumed that that's what it was, and it is. Can you see that if you do not know these kinds of things, that you're going to get stuck at the end of a question because you really don't know what it is and you don't know where it goes? So you might want to have a look back at your 142 notes, or at least maybe do a search like, I don't know, I maybe use words like standard trig identities. And if you do a search like that, it'll probably give you a list of all the common identities that you should just know, because you're probably going to meet them. Here's a couple right now. While I'm on that, so this is a side issue, here are some more trig identities. I'll give them numbers. Numbers 1, 2, 3, 4, and 5. Does anybody know what any of these 5 is equal to? And doesn't need to be the first one. Whatever one you happen to know the answer, tell me.
Is the first one sine of 2x?
Yes, it is. Anybody got one of the 4 that's left? Most people should get number 3.
That one.
Yeah. Okay, there's only 3 left. Now it's getting troublesome, isn't it?
Just to make sure for number 4, that is a +1, right?
That there?
Yeah, my screen's kind of blurry.
Should say minus. I know it looks like a plus. Somehow I've put an extra line on it. I didn't mean to. Last few seconds, then I'm going to tell you. 3 ego. Any one of those 3.
Number 2
Is
is
the last
cosine.
Number 2 is what? And then we'll get who
Cosine 2x.
it is. Someone might have been asking or telling me one of the other 2. What was that the other person was trying to say?
Is the last one tan x?
It is. I'll put that one in as tan squared. So you got to know trig identities. It's just a knowledge thing. You just memorize the darn things and you use them when you need them. And then they go away for 2 weeks, and then you get 5 questions in a row where you need them again, right? So it's not like it disappears. It just appears and disappears like a ghost thing. But here's our next one. This is similar to question 6. How do I know that that is an indefinite integral and therefore my answer will have a plus c at the end? What's the clue in the way that's written?
There's no numbers attached to the integral.
Right. They're called the limits of integration, but numbers attached to the integral makes perfect sense to me, right? That's a power rule. Might not look like a power rule because 1.6 isn't your typical power, but it is. Add 1 to the power, divide by the new power. Add 1 to the power, divide by the new power, and add c. Now we need to do style points, right? Make things look better. Now there's one rule that says the answer should look like the original. So see these 2 ugly powers? They are totally okay. Don't do anything to them. Leave them alone. What about 1 over 2.6 and 7 over 4.5? Do you think that's a typical way we would leave things? Does that look good? No, doesn't look good. So what we're going to do is we're going to do 1 divided by 2.6, which is that horrible decimal. Then I'm hitting the math button, and choice 1 turns it into a fraction. So I get 5/13ths in this guy. And 7 over 4.5, 7 divided by 4.5 is that ugly decimal. And then you go math, option 1, and you get 14/9. And that's the style points finished. In fact, that's that question finished. Pretty much 99% of the time. We don't like decimals. And we certainly don't like fractional decimals, right? We don't like 2.9 over 7.1, right? Nobody in mathematics would consider that good form. There are some exceptions to that rule. Would you agree, for instance, these powers have to be decimals because that's what they look like in the start, right? So it's not 100% you never have a decimal, but, you know, if you can get rid of them or, you know, do it in a better way, you should. This is similar to question 8. Okay, it's another indefinite integral. That just means that my answer will have lots of x's in it and finishes with a plus c. Power rule. Add 1 to the power. Divide by new power. The number 2 just gets you 2x. And this guy is one of these fellas. What's the antiderivative of this fraction?
That'd be 4 times the inverse tan.
Yes. And then finish with a plus c and you're done. Can you see some questions can be really quick? Are we good? I've got deja vu on question 9, but again, that might just be me and the fact that I did it. I know I've done it with at least one class. Have we done that question? Nobody recognize it?
Don't recognize it.
Oh, good. Then we got to figure out how this thing here is going to be integrated. It's definitely got trig stuff in it, so I should be thinking, oh, trig identities. There's going to be some trig identities, or at least something is going to happen. I know where that thing there came from. I'll write it again. It's 9 secant t plus 2 tan t. That's the real question. I seem to have picked up a little plus symbol. First thing I'm going to do is distribute the secant, multiply it through. It doesn't look like that's a trig identity. That's good news. However, I still need to integrate it. The integral of secant squared, and therefore we can also get 9 secant squared, is over here. And secant tan is over here. So I'll give you a few seconds to think about that guy, and I'm just going to mute you. I'm getting some background sound. Right, so look at this guy. What's the antiderivative or integral of secant squared?
It'd be 9 tan.
Agreed. Okay, it's not x's, but that's not a big deal, right? It's just 9 tan of t rather than 9 tan of x. And this guy's got a 2, so I know it's going to have a 2 at the front. And I just need to find a secant tan. And what's the antiderivative of a secant tan?
And just a secant.
Right.
Secant.
Agreed. Finished. So there's an example of a trig integral where I didn't need any identities. I should keep these up for a second. Are there any questions about those 3? Can I move on? move on it is then. Show you this question first.
I know I got tripped over 12.
Oh, I'll do that next after this one. What we're looking at here is question 10. You see it? Have we done 12?
Do not know if we did it, but I thought I
It's
had the
not.
correct.
It's not familiar. That'll be enough then. Okay. So the first part is pretty much straightforward. We're being asked to find the antiderivative of cosine x plus 1/9 x. So I'll return and do that bit first. Okay. What is the antiderivative of cosine?
Sine.
And the antiderivative of 1/9 x? Think power rule. Wonder if it's a fraction that's causing the issue. Right, if you add 1 to the power, it's x squared. Don't you divide by the new power? So you divide by 2, and that's why you end up with an 18th. Is that why you were maybe hesitant? You weren't sure what the fraction was? I'm pretty sure you know how you do an x, right? It just goes up to an x squared. Now, that typically would be the end of the question, but in this question, they go and have a part B to it. And it says, illustrate by graphing several members of this solution. Right? And you might say, well, what do they mean by graphing it? Well, you go to this guy. You hit y equals, whoops, make sure it's on, clear that. You hit y equals, and you type in the sine of x plus, I would do brackets 1/18th, close brackets. That's the safest way of doing an 18th, x squared, plus, well, plus 0, plus 1, plus 2, plus 3, right? That kind of thing. Or plus 5, plus 10, whatever you feel like. In the pictures that they've got that you can't see anymore, they tell you that it's c equals 0, c equals 5, and c equals 10. I think they also have a -5. Now, I can't do all of those. If I leave this blank, that's c equals 0. If I then do the same equation, that's sine x plus 1/18th of x squared plus 5, that would be the second one. I'll do just one more. So it's going to be sine x one more time plus 1/18th x squared plus 10. And then I'm just going to go to my window and I'll pick negative, I know, pi to plus pi. Got to pick some window. And if I do zoom 0, which is zoom to fit, eventually, well, there we go. Curve number 1, curve number 2, very, very slowly, curve number 3. And one of the pictures will be that guy. And I'm noticing that their window is probably a little bit bigger than mine. So I'm changing that to -2 pi to +2 pi. And we stare for 5 minutes. I must have a really slow calculator. But there we go. And that looks much more like the choices that you have in the list of pictures. So one of your pictures, can you imagine? I can't draw very well, but can you imagine it was this one? And you pick it. So that's what you're meant to do in question 10. You were saying you had issues with, was it question 12? That one?
Yes.
Right, let's do that next. We've got 3 questions at the end to do, which are all application questions. So question 12, I'll get a little story behind it before we do the math. I want you to imagine that there's a big tank of water, full to the brim. Let's suppose this water has, well, who knows? It has a lot of stuff in it, but there's a hole in the bottom, and out shoots the water. It leaks out, and the rate at which it leaks out is given by the formula 400 take away 8t, and it only lasts for 50 minutes, and then the tank's empty. So you're told that the rate at which water is coming out is this number. So for instance, in the 10 seconds, right, 10 seconds into the leak happening, 400 take away 80, the water is shooting out at 300 litres a minute, right? Now, we are being asked here to find the amount of water that flows out of this tank in the first 35 minutes. Now, the amount in the first 35 minutes is that. And I'm going to replace that guy right there. Would you agree that's just a relatively straightforward, doesn't it? Just integrate the usual way, and you will get a number, and that's what they want.
Yeah, I'm kind of wondering if I had a typo or something, but
Yeah, it helps. Now, the next guy gives me a really, I don't know business, but evidently there's a thing called the marginal cost of manufacturing. And it's C dashed of X is equal to this guy. And they want to find the increase. In other words, the amount. Whenever you see a question saying the total amount, the increase, the thing, the distance, think integral. And they want to know it from going from 2,000 to 4,000. So as long as you realize that what your job is to do a really ugly integral and evaluate it at 2,000 to 4,000. Good luck with that. The numbers are really ugly. That's essentially what 13 is about. And then they have one last question, and that means we can start our new section after this. At the beginning, there are 3,000 bacteria in this story. And the rate of growth of this bacteria is 1,000 times 4 to the power of t. And they are asking, what is the population of bacteria after 1 hour? Okay. Now, if you want to find the population, I'll call it P of t. It's the integral of the rate function. So we're integrating that guy. 1000 times 4 to the t dt. I'm going to use this guy down here. Do you see this last one? This is the antiderivative of 4 to the t, 5 to the t, 4 to the x, 5 to the x, right? This one right at the bottom. So the antiderivative is going to be 1000 times 4 to the t divided by the natural log of 4 plus c. So the antiderivative of that is this. If you integrate a rate function, you get an amount function. Here, it's the amount of bacteria. Then I'm going to use this fella, because what you're telling me is that the population at time 0, which is 1000 times 4 to the power of 0 over the natural log of 4 plus c, that is equal to 3000. I'm going to go to my calculator and find out what this number is, because it's not very pretty. So it's 1000 times, oh, I could do that in my head. What's 4 to the power of 0?
One.
Yeah. Then divide it by the natural log of 4. And we get not a very pretty answer, but roughly 721.3. Add C is 3000, which means that C is what you get if you take that away from that. So it's 2278.7. So I now have my completed P of T. It is this fella, 1000 times 4 to the t over the natural log of 4. But instead of plus c, it's now plus 2278.7. Now, in my question, they want to know the bacteria after 1 hour. So I just plug in 1 here, you get the answer. If you wanted to know what it was in 10 hours, when you just plug 10 in here, right, and so on. So it's 1000 times 4 to the power of 1, which is hardly worth doing, divided by the log of 4, add 2278.7, and we get that. I'm rounding it off. And that's how you do the last question. Okay, so the applications are always a little bit different, a little bit difficult for some people because that's not their thing. They're not a scientist, they're not really an engineer, but it does show you the power of integration, what it's capable of doing. So with just a little bit of information, I can actually tell you how many bacteria, I don't know, for any amount of time you like. Are we good with that question? Okay, move on. Well, I'm going to have a quick pause because I feel I need one. Right, we'll have a quick joke, a little chance to get our brain back into gear, and then we'll start the next section, which is the last section for today. It's actually the last section in that chapter, I believe, as well. So has anybody got a joke for me?
Sadly, no.
God, you're a depressing lot. Sarah, have you got a joke for me?
I don't have any.
Kayla? You got a joke?
No, I don't. Sorry.
Okay. Then, do you know I'm going to have to do one of my old favourites? We're going to do the vampire joke. Do you know the vampire joke, Catherine? Can you remember me?
I don't remember that one.
Oh, that's good then. So that'll be new for you as well then. So 3 vampires get taken by Dracula to Transylvania in his castle, and he takes them to the top of his tallest tower, and he tells them, you're not allowed to join us unless you can prove yourself worthy. So I want you all to turn into bats and fly off, and don't come back until you've had some victims. So they do as they're told, and they turn into their bat-like form, and off they flap into the night. And 30 minutes later, the first vampire comes back, and he turns into his human form, and he's got blood dripping off his fangs. And Dracula says to him, "Oh, that's interesting. What happened?" And the vampire said, "Do you see, just over there, do you see that tree?" And Dracula goes, "Oh, yeah." Well, he says, "I flew over there. There was a woodsman there. I drank all his blood." So Dracula says, "Okay, that's good. You can join." And they wait about an hour, and the second one comes back, and he turns into his human form. And this one's not just his fangs, his whole face has got blood all over him. The whole face dripping with blood. And Dracula goes, "Wow, what happened?" And the second vampire said, "Do you see that little house down there?" And Dracula goes, "Oh, yeah." He says, "Well, I flew down there. There was a whole family there, and I drank everybody's blood." Dracula says, "Great." He says, "You can definitely join." And they wait for almost ever, and finally the last vampire bat comes back, and he turns into his human form, and his fangs are dripping with blood, and his face is dripping with blood, and his blood everywhere, clothes, everything, blood dripping off him everywhere. And Dracula looks at him and goes, "Wow, what happened?" And the vampire says, "Do you see that church tower over there?" And Dracula goes, "Oh, yeah." He says, "Well, I didn't." Come on, Anton. I didn't. No. Oh, I got a thumbs up. You're one of those, what's the word? Inscrutable. I don't know if that's the word I'm looking for. Okay. I don't know about you, but that cheered me up. Telling bad jokes always cheers me up. It gets me into the swing of things. Well, let's get started. We are now going to focus on a new chapter. And this chapter is section 5.5. And it's called the substitution rule. This is a very important section. When you have to integrate functions, and they're quite complicated ones, there's a very good chance that you're going to have to use the substitution rule to get your answer. And so, unless you've met it before, it sometimes takes a little while to kind of catch on. The first 2 or 3 examples, you'll be wondering a little bit about what's going on here, what's the process, why is it working. But hopefully by the time I finish the third one, you'll begin to see a theme. This is not a formula, like the product rule and the quotient rule are formulas. This is a process, and it allows us to integrate many, many different looking integrals. And because it can do so much, it can't really be a formula. You have to just look at it as a process. So I'm going to give you an example of that being used. Here is a classic example of the type of thing you would use the substitution rule on. See, the trick here is that the only way that we could integrate it right now would be ridiculous. Wouldn't we have to FOIL that all out and get a massively big polynomial? Can you imagine how big it would be and how ugly it would be, right? And then for every single term, wouldn't we have to use the power rule? And that's pretty much all you've got as a technique. So what we're going to do is we're going to substitute that. We are going to replace that integral by a much easier integral. And we're going to find that answer. And that simpler integral, right, the substituted one, its answer is going to then lead us to what the answer to the original was. So you might say, I wonder how that's going to work. Well, we are going to use a change in variable. We're going to use a substitution. And the substitution I'm going to use is 3x plus 5. That means that 3x plus 5 can now be replaced by u. That's going to make life a lot easier, isn't it? But it's a little bit trickier than just that. I also need to know how to turn that guy. So this fella is u to the 98. What I need to do is I need to find a way of changing that into dx. So this is where the process starts. You've got your u sub and you differentiate it with respect to x and you get 3. If you were ever wondering why the notation du by dx even exists, this is one of the reasons. Although it's not technically, and it isn't a fraction, you can do this. I call that the crossover. That's just my made up name for it. Do you know it's a bit like cross multiply, right? It's a crossover. And then, if you divide both sides by 3 in this case, do you see that I can now find out what dx is? It's 1/3 du. Now, all I'm doing in this line is sticking the third at the front. Now, if I asked you to integrate that, would you all agree it's just a power rule, no biggie? Agreed? Now, what is the power rule? Well, you add 1 to the power and you divide by the new power with a plus c. And then you do one last little thing and you're finished. What do you think the last little thing in this process called the substitution rule is? Remember, our goal is to find the integral of this. What do you think our last step should be then?
Should we substitute for u?
Yes. I don't know where that came from. There we go. Now, you think about that, isn't that a lot easier than multiplying that out, takes a couple of days, and integrating every single one of them? And isn't that a nice compact answer? Plus, it's pretty easy to find. So if you were breaking, as we do, the substitution rule into processes, choosing the u sub is step one. So doing all of this, right, is step one. Taking your integral and replacing it, as we did here, is step two. Integrating the easy guy is step three. And then converting back to the x's is step four. Let me do another one. Suppose I wanted to integrate e to the x cubed 6x squared dx. Now, right now, I'm going to tell you who the u sub is. But after this question, I'm going to show you how you find out who the u sub is going to be. So this is the integral, and this is the substitution I'm going to use. Du by dx is 3x squared. The crossover gives me 3x squared dx. Divide both sides by 3x squared, and you have got that. That's good. That's my step one done. I don't know what to do with 6x squared, so just write it down. E to the x cubed gives me e to the u, and dx gets me that. And then you say, oh, that's kind of magical. Do you see what's going to happen here? What's going to happen here?
Simplifies to 2.
Yeah, those are going to cancel, and 6 divided by 3 gets us 2. So from what was a really, funny looking you, a really ugly, impossible to do, I guess, integral, hasn't it turned into a very simple integral by the substitution process, right? 2e to the u is easy to integrate. It's 2e to the u. And to finish, replace the u with, in this case, x cubed. If you wanted to check that this question was correct, all you need to do is differentiate this, and I bet you would get 6x squared e to the x cubed. Trust me on it. If you don't, trust me, that's fine, and check it yourself. So let's look at how do you find typical u subs. I've only done 2, but in this case, the u sub was 3x plus 5. And in this second case, the u sub was x cubed. Okay. So what I'm going to do is show you tricks of the trade for identifying who a u sub would be. I'm not going to do the whole question. We're just going to look at what the u sub would be. And then later on, we'll come back and do some of these questions. So, for instance, if you ever see an ugly bracket to a power of 10 to a power of 20, right? So ugly just means it's not x. The ugly thing will typically be your u sub. Right? 3x plus 5 falls into that category. If you ever get e to the power of something, right? E to the sine x, e to the x cubed, e to the x squared plus 4, right? Anything like that. So if it isn't x, only the power is your u sub. Who do you think the u sub might be in this case?
4 sine minus 1.
It is. So if you ever get a ugly square root, the ugly thing inside the square root is typically going to be your u sub. Now, you notice the word typical wasn't me just being vague. The rules that I'm about to tell you will work 9 out of 10 times. So 9 out of 10 integrals, these will be the right u subs. I wish I could have said it was 100% successful, but there are exceptions, right? There are situations where they don't work and you have to pick a different u sub. And we'll maybe talk about them towards the end of today if we have time. What do you think the u sub might be in this case?
Whatever the number is on the bottom, I think it's the 2x squared plus x. No.
Just the thing inside the square root. If that's what you mean, I agree with you. What do you think a u sub would be if you have a fraction? It's probably a guess because most of you have never seen a u sub, but I'll take a guess.
Again, wouldn't it be the bottom?
Yeah, it is. Are you getting a feel for the typical situations where a u sub would be used? Here's a really weird one. What do you think the u sub in this question would be?
Sine x.
If you get e ugly guy, square root of ugly guy, sine of ugly guy, if it ain't an x, it's an ugly guy, right? If you get ugly guy to the power of 10, 5 over ugly guy, you know, anything that falls into that category, the ugly guy ends up being typically your u sub. Do you feel a little bit more comfortable about what the u sub part is? You don't need to worry about what the rest is. But right now, if I just said, find the u sub, do you feel you'd have a fighting chance of picking the right one? So I'm going to do 3 questions, and I'm going to let you just look at the screen. You don't need to write it down. And once I finish writing them, you can maybe tell me who the u sub would be. I'll call them number 1, 2, and 3. Right, let you have a quick look at them. I noticed 1 and 2 are too similar, so I thought I'd change one then. Right, they're all fractions, that's fine. What would the u sub in that top one be? Number 1.
2x.
This little guy here? Is that what you're thinking?
Sorry, I
E
forgot
to
to
the
unmute
2x.
myself. Yeah, you did.
Right. If it wasn't that, who do you think it might be?
Bottom half of the fraction.
Yeah. Do you notice that sometimes you're going to have to decide between two different rules which one wins? Bottom of the fraction or the 2x, right? In this particular case, it's the bottom of the fraction. What about question 2? Is it the bottom of the fraction or is it x cubed plus x?
X cubed plus X.
Correct. Is it the bottom of the fraction or sine x?
Sine X.
Okay, that's good. How many is that? Probably over 10 examples now. I might be labouring the point, but if you can't pick the right u sub, you're not going to get this question, right? If you can't do step 1, it doesn't matter if you know how to do step 2, 3, and 4, right? Because you don't know who step 1 is, right? You don't know the right u sub. And that's an important skill. So I'm going to now move over and we're going to look at the homework questions. And I'm going to make this a little bit bigger because I can. Right. Question 1, the u sub is x cubed plus 9. Not really a question because they told you who the u sub is, right? And here's our first u sub. What would the u sub in question 2 be?
Three minus 6x.
You agree there's not a lot of choice, but that is the right u sub. Oh, I was going to ask you that one until I saw the answer. Okay, what is the u sub in question 8?
1 plus cosine.
You nailed it. What's the u sub in question 9?
8 minus e to the u.
You nailed it. What about 10? And it looks downright ugly, but don't let the ugliness of it freak you out. What is the u sub?
6 times ax plus bx to the 6.
Yep. What's the u sub in 11?
37 plus e to the x.
Yep. 12?
Cosine 32t.
Yep. Weird one, but nonetheless, it is a u sub. What's the u sub in 13?
Pi t over 2.
Correct. What's the u sub in 15?
Negative x to the 31.
Correct. What's the u sub in 16?
Just the x minus 3.
Correct. 17?
The bottom half.
That's the best way to say it. Agreed. Oh, that one's told to you. That one's told to you. That one's told to you. Okay, here's one that's not told to you. What's 22?
Five minus x squared.
I think we're getting good at these. I just want to finish it now. What's 23?
1 minus 3x.
27?
4x plus 5.
28?
X squared plus 34.
29.
One plus 7x.
Yeah. And almost at the end here. Oh, a nice sneaky one. 31.
Sine 5x.
Yeah. 32. That's a puzzle, isn't it? 32.
Will that just be 8 plus 2x?
Correct. And the last one. 33.
A squared minus x to the 10.
Correct. Okay. We have killed it, stuck a hole in it, hit it over the head. We should be really good now at finding U subs. Agreed? For the typical ones. You've seen, I don't know how many we've seen, right? Close on 30. So what we're going to do now is we're just going to return and work through the entire question. And today is, well, we've got about 1 hour left, about 50 minutes actually. So I'm going to just focus on today on doing the U subs that you're told to U sub, or it's a typical U sub. And that's all we're going to get finished today. So it does mean I'm going to have to adjust your homework a little bit. You should be able to do about half of this section, but not all of it. And that's fine, because I'll just add it on to the next 2 weeks slot. So that's fine. We'll get it done. Okay, let's pick one. Right. Well, I picked the easy one. Let me scroll through to find another one. Right. This one is like question 7. And we're being asked to do the integral of x to the 5 on the top and x to the 6 take away 7 dx. And they've even told us what the U sub is. But if they hadn't told us what the U sub is, hopefully you can tell me what it would be anyway. What would the U sub in this question be?
You're not showing your screen.
You mean I can see my screen? Oh, I might have just shown you the answer to that question as well then. Okay. Would you agree that the U sub would be the ball? Right. Now, once you know the U sub, you immediately have to do all this stuff. Differentiate with respect to x. Well, that's multiplied by the power, reduce it by 1. Do what I call the crossover. And then divide both sides by 6x to the 5. And when you are finished, you should have dx equals. Then you go over here and you replace x to the 6 take away 7 with u. And for the few moments, I'm going to leave that as x to the 5, and I'm going to replace the dx with, whoops, 1 over 6x to the 5 du. And you know that the chain, when you know that the U sub technique is working when these things get cancelled out. So I'm going to call this 1/6 1 over u du. I can then integrate this, which is a natural log of u. So 1/6 of it is 1/6 the natural log of u. And then to finish, replace the u by what it was at the start. It's got a flow to it, isn't it? It's kind of you do this, then you do this, then you do this, and then you're finished. try the next one on my list. Do you recognize that this has a pretty obvious use of? We did do it a few minutes ago. I can't remember who it was, but someone told me it was 1 plus cosine t, and they were right. Now I'm going to differentiate you with respect to t, because that's the major variable. What do you get if you differentiate a cosine? Be careful.
Negative sign.
Yeah. Do you know the number of times I forget to give it the sign, or I give it a negative when it shouldn't have one? Aren't integrating and differentiating sine and cosine easy to mix up, right? So try and be careful when you do those. The crossover, and then the isolate. So I've isolated the dt. So here it's going to be the sine of t, square root of u, 1 over negative the sine of t, du. Right, the dt is this piece, and that was still there. Now, cancel. Still negative, but it's basically that. So we've taken this quite weird looking integral and it's turned into this much cleaner, hopefully simpler integral that we know how to do. How am I going to fix this so I can integrate it and use the power rule? How am I going to fix this? What am I going to call it?
U to the 1/2.
Okay, so add 1 to the power, divide by the new power, plus c. Do some style points on it. And finally, replace the u by that fella. We okay? Right, I think that's the third one we've done. Is it beginning to have a flow in your brain? There's a kind of, I do this, then I do this, then I do this. That's the process, the substitution rules process. Once you get comfortable with that, it does tend to get much easier to do these guys. So I scroll down. This is like number 9. Oh, I just realized something. I can't do a u sub if the variable is called u. Agreed? So which letter of the alphabet would you like me to use instead? Do you want a V sub or a W sub? What do you want? Pick a letter.
Z.
Okay, a Z sub. Are you happy about it only being 8 minus e to the u? We did that earlier. Now, if you differentiate z with respect to u, you get negative e to the u. When you do the crossover, And in this case, we have to isolate this guy who happens to be called U. So it's that one. That's a little bit awkward because of the letters. Do you know, if I was really confused, couldn't I just do e to the x over 8 minus e to the x squared dx, get the answer, and then just remember that when I'm finished, you know, to not call it x's anymore, and that would cure it. But
Wouldn't that be a positive? The 1 over EU?
this here, well, I'm dividing by this, so it's still a negative number I'm dividing by. You're thinking, I think, you're thinking that. Right, that is true, that negative power does become a positive when you do that. But this is negative one of these, and if you divide both sides by that, it's still negative and it's still there. Now I've got an e to the u. I have a z squared. I have a 1 over negative e to the u dz. Cancel, cancel, negative. I am looking at that guy. Okay, if I'm going to integrate this, I need to change the z. Don't I need to write it down in some way that's going to allow me to use the power rule? And it's still negative, whatever it is. What will this be called?
-2?
Agreed. So add 1 to the power, divide by the new power. Oh, now it's positive. Call it 1 over z and replace the z by that guy. That was just awkward because the u's kind of interfered with my brain process. But it's kind of nice to do that because then it makes you focus on the process and not the letters. I've been dreading this one, but I still feel I need to do it. Don't matter how ugly it is, doesn't matter where it is. There's only one guy in that list that's going to be the right use of. Anything else you pick's not going to work. And somebody did do it today. What's the use of it?
6ax plus bx to the 6.
And aren't we doing that because it's the ugly guy inside the square root? Right? Ugly guy inside the square root, good candidate for the use of. Now, when you see letters like A and B in mathematics, they are considered constants, right? They're just numbers you don't know the value to, but they're fixed numbers. So when I differentiate this fella with respect to x, 6ax just becomes 6a. It's a bit like 60x becomes 60, right? Now, if you do bx to the 6, aren't you using a power rule of differentiation? And that gets you 6bx to the 5. Are we happy about the differentiation? Does that make sense? Crossover. Okay. Divide both sides by that. That's a pretty weird looking thing. Okay, let's see what we get here. The integral. A plus bx to the 5, that's okay. Square root of u, that's good. 1 over 6a plus 6b x to the 5 du. This doesn't look right, but it is. We just have to work on it. Can you see anything that I might do with this that may help us?
Factor out the 6.
Ah, it helped us a lot, didn't it? Because now they're gone. And we are looking at 1/6, 1 over the square root of u du, which is 1/6 u to the negative a half. Right, 1 over the square root is a negative a half power. Power rule. Add 1 to the power, divide by the new power. Well, dividing by a half is like multiplying by 2. That's why that turned into a third. We're plus c. Style points. And finally, replace u with 6ax plus bx to the 6. Add c. So even something ridiculously weird looking like that, this method, the substitution method, will still allow us to integrate. Okay, who is the U sub in question 11? You may have to hit the, I think I heard it. 37 plus e to the x. Okay, guys, no pressure. You have got 2.5 minutes. Do that one. And I'll be back in 2.5 minutes. Okay, let's go for it. If you differentiate 37 plus e to the x with respect to x, the 37 disappears as a 0 and all you're left with is e to the x. If you then do the crossover and divide both sides by e to the x, and you will isolate the dx. So I'm going to have e to the x, the square root of u, times 1 over e to the x du. And I am getting deja vu here. I don't know how many times today we've had a square root of u somewhere. So hopefully you said, oh, this is going to be easy. I've done that before. You get this guy, add 1 to the power, divide by the new power, make it look pretty, style points. And then replace the u with x's. Do you get that? Hopefully. Thumbs up. Like it. Let's do this fella. Not too nasty. I need a u sub.
Hmm. 5x plus 1.
Yeah. It's kind of the only candidate. Would you agree there's not a lot of choices in this question? So with respect to x, you're just going to get 5. When you do the crossover, you're going to get 5 dx. And when you divide both sides by 5, you isolate the dx. Pretty standard. That's going to become the sine of u. And the dx is going to become 1/5 du. And just to make it look pretty, you get that guy. Okay, be careful. Antiderivative of 1/5 sine u. Antiderivative of 1/5 sine u.
Negative cosine.
Agreed. So, nothing too weird. So let's try weird. And that one is pretty weird. One of the homework questions look like that. I need a u sub. And that's not the cosine times this, that's the cosine of the sine of 3x. Who's our u sub?
Sine 3x.
Yes. Now be careful, or watch what I do here, because I'm going to be careful. I'm going to differentiate the sine of 3x, which is definitely the cosine of 3x. But don't you also get times 3 because it's a general? So it's 3 times the cosine of 3x. Do the crossover now. And divide both sides, you get 1 over 3 cosine of 3x du is equal to dx. So I'm going to get the integral of the cosine of 3x, the cosine of u, and instead of dx, 1 over 3 cosine of 3x du. Those guys cancel out. And I'm now left with 1/3 the cosine of u du. That's not hard to do. It's 1/3 the sine of u. And then replace.
So being able to cancel out something in the denominator with something in the numerator is a pretty common theme here, right?
Very, very common. Yes.
So if we don't see that, we can assume that we've done something wrong.
You've either algebraically done something wrong or you've picked the wrong u sub. Can you imagine there's going to be some situations where I think that's a u sub, but maybe this is a u sub, right?
Yeah.
And you went A when you should have went B. That's the normal indication of that, is that you don't get this cancelling out thing going on.
Okay.
That happens a lot. If you get it wrong, it's not a lot. If it does cancel out, it's a pretty good sign that you're on the right tracks. Oh, before I move on from this one, if I said to you right at the start of today, let's integrate this. Right, let's find its antiderivative. What do you think your reaction would have been? Ain't going to happen, right? How on earth are you going to find an antiderivative of something as ugly looking as that? Well, there it is. Do you see how powerful the substitution method is? That it allows us to get the integral of extremely weird looking functions. Now, we haven't got time to do this right now, but jumping ahead a little bit. Can you imagine that the next stage after finding the plus c, the indefinite ones, wouldn't it be to do the same question, but just do from x equals 0 to x equals pi? So there isn't a big difference, isn't there, between a definite integral and what we are doing in definite integrals. So that jump won't be a big one, right? You'll still get the answer, but without the plus c. Instead, you'll do a vertical line from x equals 1 to x equals 2, and you'll evaluate it. So when you're finished, the answer will be some kind of number. And that's okay. Numbers are good. Any questions? Are we still with us? You feeling better every time? Getting a little bit more comfortable? That's what I'm hoping.
Maybe.
Okay. Eventually, I'm hoping that it will work. This is like 14. We're moving into some of the more exotic u subs. Who is the u sub in this question?
1 over x to the 5th.
Yes. And we're using kind of, my rule is E is the ugly guy is your u sub, right? Now, if you want to differentiate this, I'm going to have one extra line. Would you agree if you want to integrate or differentiate a power, don't you need a power? You can't leave it as 1 over x to the 5, right? You have to call it this guy. So when I differentiate with respect to x, it's multiplied by the power and reduce it by 1 because it's differentiation we're doing. And I'll do the crossover. And then I'll divide both sides by this ugly fella. And then I'm going to do some more algebra. fractions with negative powers in them don't normally work well. They aren't easy to deal with and simplify with. Are you okay with the x to the negative 6 in the bottom is the same as an x to the 6 on the top? Remember that rule, 1 over a negative power is the same as a positive power. That's going to be helpful there. So, e to the u over x to the 6 times negative x to the 6 over 5 du. This here was dx. Now that you cancel with me kind of thing means that we are now looking at, oh, a really nice integral. We're finished. Now, if this question had been the integral from 0 to, let's do it, not 0. If this had been the integral from 1 to 2 of this guy, then I would have still done this bit exactly the same way that I did it. But wouldn't I then do from x equals 1 to x equals 2? So do you see the difference in a definite integral and an indefinite integral is an indefinite integral, you write the formula down with a plus c, and in a definite integral, you use the formula evaluated at 1 and 2. That's really the only difference. So although we haven't done that many of these questions, I don't think I need to, because you pretty much 90% of the work is the same work, right? What you do is the same thing. Who is the U sub in this question?
The denominator?
Correct. When you differentiate with respect to z, e to the z gets you e to the z, and 22z just gets you the number 22. And the crossover looks like that. And when you divide both sides, you get that. So this now becomes the integral of, on the bottom, u. Right now, the top looks like that. The dz looks like that. The typical cancel. And that's what we get. Natural log returned to the original variable. A very clean use up, right? Not too much weird stuff going on. Came out relatively smoothly. Pause for a minute. Any questions? We should be getting better and better. Every time you see one, you're adding to your experience. A lot of mathematics, being good at mathematics, is just sheer perseverance. If you differentiate 500 or 600 functions, won't you be really good at differentiating? Well, if you do 60 or 70 or 80 substitution questions, you will get really good at doing substitution. If you only do a few of them and say, yeah, I think I know what's going on here, then you're not always going to be that good, because there are so many functions in the world. Couldn't there be one that you've never noticed or saw before that could turn up? And it's still a substitution, but you haven't had enough experience to see something like it before to know where to go. So it's, can't emphasize enough why I'm spending so much time doing these guys. Right, these ones all have it, so I'm not going to do those. Done one like that, I'm not going to do that. Yeah, we're getting close to the end. 27, 28, 228. Oh, changed my mind. Don't do it. Oh, no, changed my mind again. I want to show you, I wasn't expecting this to happen, but I want to show you now that it has, that sometimes you can do a U-sub and it looks like it's going to go wrong, but it's in fact correct. But sometimes you just have to do workarounds, right? Like fixes, just one-off fixes. Now, in the big scheme of things, isn't the U-sub x squared plus 34? You agree? And it is the correct U-sub, right? That's not the problem. So let me just get that out of the way. And we get 2x. And when I do the crossover, we get this. And when I isolate, we get this. So this is going to be the first example of questions that don't fit the usual substitution rule method. This one, the U-sub is correct, but the math is going in a few minutes from now is going to go weird on you. And that's okay, we'll show you to survive. In later questions, when I see you next week, we're going to show you questions where the typical U-sub doesn't work, and we have to think of a different U-sub that will work. So that's a different issue. So I have x cubed. I have the square root of u, nothing special. I have 1 over 2x du. Now at this point here, wouldn't that x cubed cancel out this guy? Isn't that what happens every other typical U-sub? Agreed? And so that very often means you've screwed up, but it isn't always you've screwed up. This is a situation where that is actually what happens. So we have to figure out a workaround. If you cancel that, you're going to have 1/2 x squared, the square root of u du. The goal here is to have nothing but u's. And most of the time, they disappear on you and you don't worry about it, right? You've only got u's. But not this time. X squared is a little orphan. It's sticking out there like a sore thumb, getting in the way of the next step. So I'm going to return to this fella. And I'm going to use them to fix this problem. If you rearrange this by subtracting 34 from both sides, can x squared be replaced by u minus 34? So I'm going to go here and I'm going to go 1/2 u take away 34 square root of u du. So I've fixed the orphan x squared, right? It's gone now. I have introduced a new problem, but we can fix that as well. And we did this, oh God, I don't know if we did it on Tuesday, but we certainly did it sometime in the last few days. What do you think I'm going to replace the square root of u with here to allow me to go a bit further?
You did that 1/2.
Great. And now I'm going to distribute it. A half times that gets me 1/2 u to the 3/2. And a half times that times that times that gets me negative 17 u to the half. At this point here, aren't we good to go? Don't we now know how to find antiderivatives, right? We could just do power rules. Not the prettiest answer in the world, but add 1 to the power. And divide by 5/2 is the same as multiplying by 2/5. So that's why that's a fifth. Add 1 to the power. Divide by 3/2 is like 2/3. Yikes, 34/3. Style points now. Square root of u to the 5. Square root of u cubed. What's my last line? What am I going to do to finish this question off?
Substitute the u back in.
So, I mean, this question was doable. So, someone earlier, and I don't know, was it you, Matt, they were saying, or something, anyway, was saying, do you typically get a guy in the top cancelling a guy in the bottom? And the answer is yes. That's a really good sign, the x cubes cancel. But there are exceptions to every single situation. Can you see this as an exception where there was an x squared left over? Now, sometimes that just means you screwed up, but other times it just means you have to do more work, but it can be done. I think I've got an idea what I'm going to do next. A little bit ahead of the game, but at least it'll get your mind thinking. Got 10 minutes, so let's get your poor brain into overdrive here, right? The last charge. I am going to give you integrals. Oops, let me change that. Just start again. That's fair. Unusual u-subs. You can't really predict these. You just got to get experience in seeing them. So everyone I'm showing you is new. But the minute you see another one like this, try and remember what we did here. What do you think the u-sub in this case is going to be? Not a lot of choices, right?
I'd probably say x.
Right. If you do a u-sub of x, can you trust me that the end of the day, that's what your answer looks like? In other words, you didn't get any benefit. So a u-sub of x is never, ever going to be a good u-sub. So if you have that as one of your choices, forget about it. So who's left? Unusual.
Natural log of x.
Yep. Now, we haven't time to show you today that that works, but can you trust me it works? What about the natural log of x cubed over x?
The same thing.
Yeah. What about square log thingy bob over x?
Same.
Same thing. Do you see that once you've seen one, haven't you seen lots of variations in the same theme? When there's a log floating about, you might want to look at it as a possible candidate for the use of. The usual use of in this case would be sine squared x, right? It's the bottom of a fraction. 9 times out of 10, that's exactly the right use of, but not this one. That doesn't work. And sometimes you're going to pick the wrong use of, and you won't know to about 4 or 5 minutes into your working, oh, no, this isn't going to work, right? Any other suggestion in this case?
Cosine x.
Correct. What made you think of that? Oh, sorry. Wrong. Think again. You were almost right. You just picked the wrong guy. Sin x. Now you might think, how's the sin x going to work? Well, can you see you're going to get a u squared on the bottom, which is good. What's going to happen to the cosine x? Well, when you differentiate sin x, don't you get a cosine x that will get killed off? What about cosine x over sine cubed x? Who's your u sub going to be?
Sine x.
Yep. Suppose it's sine cubed plus 1.
Sine x plus 1.
Oh, yeah, I understand that. It makes sense that I should do that, but cut it back.
Would it still just be sine x?
Yep. With a whole big ugly cube on it, still sine x. Now you might think, well, why is it just sine x? And it's not so much the u sub. Isn't the cosine x has to go away? Doesn't the cosine x have to get killed off? Won't a single sine kill off a single cosine? If you tried anything else like a sine squared or a sine cubed or a whatever, something like that, you'd probably find out that you didn't kill it off. You generate more than you destroy. Let me see if I can find some others right now. Here's one. This is question 25. Both of them say 27x, by the way. While you're thinking about it, I'm going to rewrite it so it's a little bit cleaner. Okay. Who's the u sub in this question?
Cosine 27x.
You see what I'm hoping you've done there? Have you learnt from these guys that when you see things in the same look, you tend to do the same u subs? You know, when you see a log floating about, don't you tend to do that as your u sub? Right? And if you see enough of them, that becomes a very, very common guy. Here's an unusual trig one. If you get this one, you deserve the day off. Last one of the day. There are lots of possible answers, but only one works.
Tangent.
Oh, you nailed it, Sarah. Were you lucky, or was there a reason you picked it? Because it's the right answer.
I remember a lot of this from the last class.
Ah, okay, so you've seen this. But that's good that you remember it, so none to take away from that. You did remember it. Can anybody think of why that is the good choice? Instead of, I don't know, secant squared or tan to the 8 or some other, whatever. Why that one is a good one? What's special about it that works really well with this question and no other?
Derivative of tan is secant squared.
And so that is going to get killed off. That will end up as u to the 8th. So sometimes when you're picking your u sub, don't just use it to make the bottom nice or some other piece nice. Also have as the back of your mind, if I differentiated this, what would it get rid of? Well, if you differentiate this, it get rid of the secant squared. If you differentiate cosine 27x, it'll get rid of the sine 27x. You see, they kind of help you along the road in many respects. Well, you've done well to hang in here because that's been a lot of heavy duty, me writing fast and doing lots of questions. And as I said earlier, and once we leave, I'll try and remember to fix it, but I will fix it before Sunday, that the last homework, this one, will now not be due midnight Sunday because we haven't covered it all. So your homework will finish on, what's the number just before this one? Let me find it. 5-4, sorry. You will finish on 5-4, right? Which is indefinite integrals, I think, isn't it? Yeah. But if you've got time, and I hope you do, will you try some of the questions in the substitution one, just so you don't get rusty, and let a week go by before you do them again? It's probably good to keep your hand in. Okay, say hi everybody, and that will be us for today.
Thank you, Professor.
You're welcome. Bye-bye. Bye-bye, Ryan.
Thank you.
You're welcome. Are you, oh, she's gone. Sarah, are you out of here? Rena, are you out of here? Rena, do you have a question? You're still here.
Oh, no.
Okay then.
Yeah, thank you.
You're welcome. Have a great day.
You too.
See you Tuesday.